Hey guys, welcome to another session of the Cloud Chat. And today we'll be talking about some of the AWS reference architectures that AWS has hosted on their website. And to take us through the web and mobile application reference architecture, Chama, take the lead.
Yeah, so I think Damien, today our main idea is to sort of go through some Lambda reference architectures which AWS has provided itself. So basically some good use cases which AWS thinks that Lambda is very useful. So let's see the recommended architectures. So we'll try to first do the web and mobile application, the backend architectures first, and then when we have time, we can do the rest of the Lambda architectures in a different session. All right, let me share my
Definitely.
screen.
All right.
Okay. Yeah, so this is the web page where they have shared, like they have many other resources as well, like AWS has put their resources out in this web page. So we'll link this link to this like web page in our description. Okay, so let's go into web application. So it's basically a web GitHub repository where they have shared the entire project reference architecture and the code to deploy it. So yeah, first let's go one by one. No? All right. Okay. So let's come from the left hand side. So here we have the route. So there are devices. So let's say it's a mobile application, web application. Basically, the interfaces where the system connects to, and there's route 53. So let's say if someone puts the application URL, that will hit the route 53 endpoint, and then they have two other services which are MS Incognito and Amplify Console. So Cognito is more like their authentication, authorization hosted service which AWS offers. So that handles everything from user authorization, then basically two-factor authentication, like all sort of security related activities as well. And then they have used Amplify Console. So this Amplify is more like a framework which connects like many AWS services together, and they have some good JavaScript libraries which can be used directly with the web application and the mobile application, which connects basically to the entire system architecture. So basically it would connect to the MS Incognito system, and then it will also connect to the AWS web API. API gateway, sorry. So we have a API gateway. Yeah.
Shall we just give an overview of what Route 53, Amplify, and Cognito does? So just to give an overview, so Route 53 is sort of like the DNS resolver of Amazon, and that's where you would resolve your domain names or your subdomain names and your paths over to the relevant instances that are actually running an application. And there's something a bit weird about this, because normally what would happen is you would see an arrow pointing from Route 53 to Amplify or Cognito, but maybe we can go into depth to just understand what exactly they're meaning by this. And Chamat, can you go into a bit into depth about what exactly Amplify is and what it provides?
Yeah, sure. So basically, Amplify is like a set of tools which AWS like basically we can call it a library which connects many of the AWS tools together, and we can use it as like a sort of a wrapper. But this AWS console, Amplify console here means there's a web in the AWS console. There's the Amplify console we can use nowadays. So basically, we can create an app on Amplify, which then we can connect to the Git repository. So as you can see on the top, we can add the CI/CD pipeline as well into this now. So basically, we can deploy our serverless functions, the Lambda functions, through the Amplify console, which then sort of deploy the infrastructure there. And the best thing about Amplify, which like what I really like about Amplify is the connectivity it gives with the other services. For example, if we are using it on React or React Native, we can directly use like Amplify.API, so Amplify.Cognito.signin, like things like that, where it's very abstract, which underlying like hide many of the implementation details which we can really get started on. So I'd say Amplify is more like a very good place to start off, like start of a serverless project or like a very microservices oriented project, and it's all managed for us. So we don't have anything to worry about the scalability or things like that. And
So basically Amplify does everything from, like, usually if you would code in CloudFormation templates or Terraform scripts, what Amplify does is it's just a graphical user interface that just does everything for you. So you can basically get a project up and running within maybe 5 or 10 minutes.
Yes,
just
exactly.
by clicking and configuring the routes and doing all that stuff just from one place.
Let me show you quickly show you these services which they connect to. So it's very easy to connect with all these services with one single library. So it's more like a AWS CLI, but in a very application oriented manner. So we can use it inside a JS library, like a JS application and things like that. So something like that.
So they also provide stuff like, so they directly integrate push notifications, CI/CD. I suppose what they use there is the AWS CI/CD flows, and you have GraphQL, REST, storage, probably S3 and DBs. Oh no, you have a different data store as well. So that's probably the DB. Storage would be S3, I guess. PR previews, okay, and users, Cognito, push notifications, custom domains, courtesy of Route 53, authentication. Awesome. So it's basically like, it's like an amalgamation of a lot of services
together. Yeah,
they're just exposed in a simple UI.
Yeah. So basically, what we deal with is just AWS Amplify. We don't care about whatever happening in the behind. I mean, as a starter kit, it would be very useful. So I'd say there are many similarities if we consider Amplify and Firebase, maybe. Like yeah, I can say that. So it's very abstract, like the underlying architecture. We are very like doing a high level implementation when we use Amplify. Okay, let's go into our.
Got it.
Yeah. Our diagram. So okay, so yeah, I think we explain up to Amplify. So yeah, Amazon Cognito is the managed service for basically authorization and user management. Yeah, authentication. So it's very scalable, and it's like managed by AWS, and I think it's been used by many clients as well. Yeah, so I think up to that, what we can see is very straightforward architecture. I mean, like using Cognito and Route 53, it's like very dedicated AWS services, which usually tend to be used by many developers and like enterprises. So then this is the API gateway. So AWS API gateway has been used here. So what it does is it will connect with all the other resources and use it as a sort of a REST API, like a API gateway mainly. So let's say we have functions. So here we can see add to do, complete to do, delete to do, like that. So let's assume / to do post should be go to this add to do function. So something like that. So things like that can be very easily routed by the API gateway. So this is using
so this is AWS API gateway, right?
Yeah. So this is a managed service again by AWS, and we don't have to worry about anything other than just plug in the services and say, okay, this is a post request, go to this function. This is a get request, go to this function. And we can also like do dev prod staging environments and things like that with API gateway. I think it's very helpful. Yeah, and that I think this architecture is very good with Lambda, because it's as you can see, everything is microservices and everything is sort of serverless, we can call it. I think this is why AWS also like pushes Lambda like to go out into production and things like that, because a simple use case like a to-do application can benefit a lot from this sort of a architecture, and we actually don't need to bother much about the infrastructure here. Yeah, so then the middle layer, Damien, I think we have talked about like Lambda functions previously as well, like in the TruthCBR architecture. So again, if we do a recap here, so Lambda function it's more like a function as a service, where we just write a very small part of the logic, like the business logic. So let's say add to do. So that add to do Lambda function will only handle that part of the code base, nothing else. So it's basically like a very focused function. So that's why we call it function as a service. And here we have a stack of Lambda functions which are very independent from each other. So add to do, complete to do, delete to do, those are independent functions, and those can scale again like massively with the AWS infrastructure. So that's very nice to have that in the middle as a compute source. So yeah, so then they have added the database. I'm trying to figure out which one is this one. Can you remember the symbol? Is it a DynamoDB?
That's a data store, I think. That would be either an RDS instance. I think in Amplify you can actually select what you want.
Yeah.
If you want a NoSQL or if you want
it says
SQL or
AWS DynamoDB, I guess. This the sign shows that.
Okay.
Yeah. So yeah. So I think
they change the signs every day. So
yeah, I was used to like the old nice the icons were there a few years back.
Yeah.
So yeah, so everything is connected to Amplify, as you can see, like the Amplify console is there. So this should be connected to the Amplify service, which they have provisioned. So yeah, it's a pretty straightforward architecture, I'd say, Damien. What do you think? Any thoughts on this? So basically, this has the compute power, this has the data storage, the database layer, then this has the API layer, then it has the authentication authorizer, then it has basically the DNS services here.
Correct. So this is sort of like a very simple way to get maybe a very simple application up and running. But one thing I see here is, if you just talk a bit about the cons, is that I suppose you can't really customize a lot of stuff, right? The way you want. So the customization would not be that ideal, I guess, here.
Yeah, I think there'd be obviously like very limitation, like cons. Yeah. So,
yeah. But if you talk about the pros, I think you can get this up and running in maybe like 5 or 10 minutes. If you have the idea in the head, okay, you know what add to do has to do, complete to do has to do, you can just build this backend, like I think within 10 or 15 minutes, because it's just a bunch of serverless functions. And you already, I suppose, using the Amplify SDK, you can just easily, from the function itself, you can connect directly to the data store, right?
Yeah, that's true. So I think Amplify
you
also,
don't have to worry about stuff like libraries and all that other stuff. Yeah.
So yeah, sometimes let's say if we just have this API gateway, we need another layer. Like we need another layer in our application to call this API endpoint. But if we have something like Amplify, it would just directly call that function. So it basically hides some implementation detail. It's I'd say this architecture is very good for a very basic system. And if we want to go out like very quickly, proof of concept, maybe that this would be really useful for a mobile application and a web, like a simple web application. I think this would be very, very useful. Yeah. So
is it possible to, instead of using API gateway for the to-do API, is it possible to use something like AppSync, which is GraphQL?
I think we could, yeah. But then, the logic would be on AppSync, basically having the GraphQL.
So the schemas would be
that. Yeah, I saw somewhere we have, here we have either GraphQL or S. Yeah, so it basically both is supported. Yeah, I think Amplify has like developed very much from the past, like maybe the year, and it has like come to a very good level now. Yeah, I don't have much in-depth experience, but I've used it a couple of times with like a very quick application, but just using a REST API and a data store.
I think it's also really good for prototyping.
Yeah, that's what. Just getting app out would be the much faster, and you have like the hosted pages like we get from Cognito, so we can connect them and do all those things with a very few lines of code. Yeah. So yeah, I think pros side, one more pro would be doing the Lambda functions would like make us like language independent, so we can write any sort of any function in any different language if we need to, because it sort of separates that. And in terms of scalability, I think let's say the most used Lambda function can be the get all to do, maybe, because every day, let's say we open the app, it just loads the get to do, and a delete to do might be less priority. So it's very good to have this separation between the functions, and that's one function would dedicatedly do that function, and they will just shut off.
And of course, another cool thing is like inbuilt into Lambda, AWS Lambda is the ability to scale automatically, right?
Yeah,
so we don't
exactly.
have to define scaling rules. I mean, it's pretty simple. Yeah.
And this function should be very fast because it just do one job and just shut it down. And with the DynamoDB together, it should be super fast to get it out, and cost effective as well, I'd say, for a like a basic company, maybe, like, because they charge in like 1,000 requests, 10,000, like in millions. So that's how they sort of calculate the billing and the number of seconds the system, like the Lambda function is up.
I think another pro would be that if you go to set all this up yourself, you have to define VPC rules, you have to define egress rules. I suppose Amplify does all that for you. So
yeah, exactly. Yeah. And a similar way we have done, like, we can do this would be using serverless framework. I think we discussed that a bit in detail on our Clued CBR video as well, like the first one we did. So this would be like pretty much same with serverless framework, because what it does is basically do this infrastructure part like for us, like basically to handle everything directly, and we can manage the serverless.yml file and define all this API gateway logic and everything like that, route to functions.
Correct. Yes, that's quite true. But is it possible for serverless to like provide all of it in one place? So for example, can you define cognito conditions in the serverless YAML? Can you define data stores? Like, can you link? I don't think you can directly link a data store in serverless, right?
You can link, and even like there's like sort of segments we can create infrastructure using serverless files.
I didn't know that. Okay.
I think we'll just do a quick. As I remember, there's a lot of.
I think there's a sample serverless file that I always refer.
Yeah, there's like a YAML file you have.
Yes, it has all the latest stuff.
You just go to AWS examples, hello world, Node.js maybe. Should have some guide. So basically,
if you can just open this link.
Oh yeah. So I think we can connect all the services there.
Yeah. So I just refer to this whenever I need to do something in serverless. Yeah. So this supports
we can link CloudFront. Yeah. API gateway, then even we can manage the keys, API keys for API gateway within the serverless YAML.
Or you can set up quotas, you can set up API throttling, you can set up your application load balancer, your HTTP API.
So IAM rules, then
IAM rules, stack policies. I would say the pro of using Amplify over this is that here you have to configure everything yourself.
Yeah, you like there's more like this is more like bit like harder than the Amplify framework directly because we should know some things before doing so. Even creating a function, we need to know what this does and things like that. So, and here even we can like link the VPC details and sort of everything we need to. And this is very good if we are going like a very enterprise grade application on this one. I mean, with Lambda functions and all.
There's a lot of configurability here.
Yeah. So again, back
and
to
also another cool thing is that with serverless, say you want to switch to GCP or something of it, it's really simple.
Yeah. We just need to change the things and
just need to switch the stuff in the serverless file, and you're good to go.
Yeah, that's very good. But I feel like there might be limitations if we stick to, let's say, Cognito and things like that. There can be limitations. But I haven't like done a full migration among different providers with serverless yet.
Yeah, even I haven't done that because personally, personally in the enterprise domain, we don't really use serverless a lot. Like in the industries that I have worked in, we haven't used serverless. We do use serverless, but not to the level where we would need to think about migrations and all that stuff. So normally what we have used serverless for is like background tasks, stuff that are not exposed to the user. So for example,
like sending an email or something like that.
Something like that, yes. Or maybe if it's an event-based service, you would have SQS and you would have a serverless function, read in from that and push into something else. We would have serverless for stuff like that, but not as direct user-facing applications here. So,
like
for example,
not the core, but for like side work,
exactly.
Like, minor stuff.
Minor stuff that stuff that we don't need to offload that compute process onto the main ECS or EKS stack.
Exactly.
I
think Lambda is a very good event-driven architecture. If you are doing something like that, let's say, it can trigger like we have step functions and things like that in Lambda. It's very cool for those stuff. Yeah.
Correct. So one thing I remember we used serverless for was cropping profile photos.
Oh, that's a good use case.
we don't need to burden the rest of our stack with that. We just have serverless functions, just go into whatever you want and it'll crop it into, because it's not business critical.
Yeah, and because of that, like you just need to do that one thing correctly.
Yeah.
It's very good to have it. Actually, I've done something similar. I guess it's basically transferring basically storing images, like multiple versions of the image or something like that with the Lambda function, and it's very straightforward. You can connect S3 bucket and
correct. Yes.
I think S3. Okay, then what do we have? So I think if we just go into some cons on this architecture, Damien, I think from an enterprise perspective and maybe from a implementation perspective, as we discussed, like the one thing we would agree on is like the customizability we'll have to face, like up to which level can we customize some solution like this.
Correct. Yes. So personally, on like thinking as a developer, a backend developer, I don't like that there isn't a lot of customizability here. I prefer to know what's going on in the application, because say you have some sort of bug or something crashes, you have to know, okay, what are the scaling policies you have set and what are the rules you have. Okay, maybe this is a required feature, maybe this is not, and stuff like that. So I don't think you have that level of knowledge. You can get that level of customization here using this architecture. So, which is why I said it's great, it's cool, it's really awesome for a POC or really simple project. But if you want to scale it up and you want to have hundreds of thousands of visitors on your website and you have to do that sort of computing, this would be sort of an issue. So another thing here would be, again, this is something we talked about before, which would be serverless limits. So the amount of Lambda functions you can actually run in your account, you have hard limits on that. You can request AWS to increase them, but you still have certain service limits on what AWS actually can do. And for really sort of enterprise user heavy and compute heavy sort of backend, this really wouldn't scale that well, in my opinion. Another thing is, again, this is something we talked about before, which is the cold start times. So the first person to log in and use this for the day would be he'll get fed up of this basically. And he'll be like, okay, why isn't this working? Come on, why is it still loading and stuff like that? So yeah, there's stuff like that. And also another thing here is that we would be directly connecting our GitHub or whatever source code directly into Amplify. And personally, I don't really like that, because that would mean that my code, which is really valuable, would be directly connected into AWS. So I prefer, like, this is a personal opinion, but I prefer self-hosted code, either a GitHub server or a GitLab server or something like that, that is running on an EC2 server that is encrypted, and that where your source code just doesn't leak onto anywhere. There's no chance of there is a chance, but the chance is less of your source code actually leaking. So I don't really like the idea of directly integrating the source code directly into Amazon's CI/CD workflows here. because that would mean we depend on them to build and do all that other sort of stuff. I mean, those are just quirks, those are personal opinions, but again, as I said, this would be awesome if you just got an idea and was like, okay, I need to build this to see if this works. And you can just get this up and running in 10 minutes instead of having to go and write CloudFormation templates, Terraform scripts, Helm charts, and stuff like that, and trying to figure out, okay, what sort of rate limiting do I have to do? What are my scaling policies? Instead of figuring all that out, just thinking about your application and just letting AWS just do its thing. I mean, this is awesome in that context.
Yeah, and the like it's much better than the monolith architect, which we like. If we are starting up, like just version 1.02, maybe we can run a very good solution on this.
Exactly. So this is a really cool alternative to writing a monolith, because with a monolith, it's about 2 or 3 years down the line, it's going to be very hard to sort of break it up into microservices or to modernize it. But with something like this, where you already have segregation of different functions, it's relatively easier to move. Okay, so say you want to make add to do and complete to do much more. You want to add more business logic into it, and you decide, okay, I need to move this into microservices. It's pretty simple. You already have that segregation of functions, and you have the segregation of domains there. So it's pretty easy to just take add to do. Okay, this is no longer going to be a Lambda function. We are going to write this as a Java service, or we are going to write this as a Go service, and we are going to deploy this on ECS or EKS or whatever. And you just need to route your traffic into that. So this is also a cool starting point. I mean, you can easily create your engineering solution from this, starting from this.
That's really true. Yeah. I think this gives a good like a Lambda reference architecture for like web applications. So maybe I think we can go into the next one. No?
Yes, we can. I think switch into mobile.
Yeah. Okay. Nice. So let's go into mobile. They had the diagram here separately. Okay, so this is a bit of a different diagram from the last one. Let's try to analyze it first.
Wow, okay. It's 3D. Okay, so first thing I can tell you is this was not drawn by an engineer. This was drawn by some sort of graphic artist.
I think, yeah, AWS has two versions of the architecture. So this is one way, and the other one would be the plain icon-based one.
Which is what we prefer.
Yeah. We don't need this level of things. Okay, so this is basically a mobile application, and the backend is done on Lambda. So basically the mobile backend is on Lambda, and here we can see mobile users are there. So there's the mobile application, and then we have the API gateway again here, and we have AWS Cognito once again. So it uses authentication authorization from AWS Cognito, but I think this one directly uses Cognito without using any other like amplifier or anything like that, because I can't see amplify yet. Yeah, I think it's just pure AWS services directly. So it should be the AWS JS, not the amplify JS library.
The AWS SDK.
Yeah, SDK. So then we have a S3 bucket to have the media files.
Yeah.
And we have CloudFront here for CDN. Yeah, so then it connects back to the mobile application. Okay, that's good. Then what we have is, API gateway has multiple Lambda functions. So Lambda function 1, 2, 3, 1, 4, 3. And what it does is, some Lambda functions do data storage, some does mobile push notifications, and some does a cloud search, search engine. And so data store basically does connect to the DynamoDB DB. Yeah, that's the DB. Okay, this is the DB, I guess. And so this is a cool thing here, what they have done, like tried to show here. So basically, after a record is written into the DynamoDB, it will trigger another function, another Lambda function, and then that will.
That's sort of maybe like an indexing function.
Yeah, so that basically pushes into the cloud search service, which goes okay like a quick search engine, quick indexing tool maybe they can use directly to like autocomplete or auto suggest things like that. Yeah, that's good. Okay, so then we have MS and SNS for push notifications, and the users get the push notification. Okay, I think it's pretty straightforward. What do you think? Just looking at like after
It
we go through
looks,
one.
yeah. I love the fact that they have S3 plus CloudFront,
Yeah.
because this is a huge performance gain there itself.
Yeah, because some people try not to use CloudFront. I'm not sure
Yeah,
why, but if you use CloudFront, it's a huge advantage. Like in terms of even routing, even like you can
exactly.
have
Yes.
multiple routes and things like that.
This
Origins.
this architecture actually makes sense for a mobile application, because most of the business logic would actually be on the mobile app itself. You would only need your backend because let's put it this way: if you take a web app and a mobile app, the reason we offload most of the business logic from a front end in a web app to your backend is because, let's face it, we don't want to overburden the browsers. We want to make sure that, okay, the browser goes, the web app is as smooth as possible, and everything else happens on the backend. Some mobile apps are like that as well. So there are some mobile apps that entirely depend on the backend. For example, e-commerce apps like Amazon, eBay, they can't function without the backend. But for a mobile app, which say has a lot of business logic on the front and only uses the backend for other stuff like offloading stuff, searching, storing data, and stuff like that, this is a superb architecture again. So again, here it makes sense that Cognito is separate, and S3 is separate, and API gateway is separate. And via the API gateway, you have these different Lambda functions that just do all of this stuff. So this architecture actually makes a lot of sense. But again, if you talk about the pros, if you talk about the cons, this would not ideally scale up a lot if your mobile application has a lot of needs a lot of backend processing. So, for example, if it's like an e-commerce site, or if it's a banking site or something like that, or it's maybe some other sort of online store or something like that, where you need to always get new data, you need to get push notifications, you need to do big data processing, you need to do all that stuff, then the Lambda part of it would not make sense. But if it's a mobile app where most of the business logic is actually on the app, then this would totally make sense.
Yeah, even that to-do example we have had in the red
exactly.
part. So something like that, like this
exactly.
is like too much even for that.
This is actually, yeah.
So
yes.
this is really good for something like that, and even like some mid-level of like scale, like even like after prototyping, after going with beta version, they can have a production-ready application with this full architecture.
Right. Yes.
Yeah.
So just a disclaimer here: I have never worked with Cloud Search before.
Yeah, that's it. I'm also not sure. I was actually going to do a Google search here.
I think Cloud Search is an alternative to Elasticsearch. It's more of a fully managed service. Yeah. It's the same thing. It's the same thing as Elasticsearch, but it's, I think, it's built in-house.
All right. So it's more like a free text search and autocomplete search. Yeah, I think it makes sense. Yeah. So it's basically Elasticsearch in maybe the previous version of Elasticsearch, I'd say.
Probably is. So yeah, I wouldn't go for Cloud Search. I would use Elasticsearch.
Because Elasticsearch once again like gives more like customization, like customizable.
Yes.
Yeah, you can do queries and
exactly. So here again, like what I said before, this totally makes sense having S3 and CloudFront, and the advantages far outweigh the disadvantages, like the cost and stuff like that. So say you have user avatars, or your user pushes media files. With CloudFront, CloudFront is basically a CDN here, and you won't. It would be faster to fetch it from CloudFront rather than fetching it from S3, because in CloudFront it caches and it provides so much more features than directly just pulling it out of S3. And I think here, another nice thing here is SNS. So using simple notification service in Amazon, the Amazon AWS SNS, you can directly again push mobile applications directly into your mobile app. But I think for this, you would actually need to specifically use the AWS SDK here, because I can't remember if SNS actually uses Firebase, if it has support to customize Firebase notifications and Apple notifications.
APN, yeah.
Yeah, APN notifications. So I'm not sure if I can't remember if it allows that, but
I think we can connect them, and yeah, I think we can. It supports both like FCM and I think
Okay.
Firebase cloud messaging and APN. Yeah,
okay.
let's just do a double check on that as well.
In that case, it's completely awesome.
Yeah, because it just works on both of them.
Just we know SMTP, we know SNS.
Mobile push. We have SNS topic.
App endpoints, publish messages, SNS topic, and it just says it goes to them. Probably. Okay, that's weird.
I'll say iOS.
Just search for FCM.
Sorry?
Let me just do a
okay, mobile push notifications. It says
FCM.
Yeah, here it says you send push notification one of the
using, you can use APN, Baidu, FCM. Yeah. Awesome. So you have to do that you have to do that setup. You have to do that setup separately.
Yeah.
But,
yeah.
You can
do it. You can directly use Firebase here, both iOS and Android supported natively. So you can get rid of this and call the Lambda function can call that Firebase, maybe a function or the SDK.
The only disadvantage there is you will be going out of this ecosystem.
Yeah,
so you would be going out of AWS here just to directly call Firebase, but I mean that's a small issue.
Yeah, and a notification. Let's say we have a generic notification function. It doesn't change. I mean, like for a long time, there's no.
Exactly, it's all abstracted here. So I like that. I like that option there as well. It's all I see here is good.
Yeah, good stuff. Yeah, I think it makes more sense to a mobile backend rather than the web app we just talked a few minutes back.
Yes, this doesn't make sense for a web app because again,
you need more and more.
You will need a lot of processing just for all of this stuff, but because it's a mobile app, you can just have all that business logic on the mobile app itself.
Yeah, that's true.
And it also makes sense that Cognito is connected separately because you would probably have a login page and sign up page on a mobile app. It makes sense that the CDN it comes separately. It makes sense that the API gateway goes out separately as well. So yeah, all makes sense. And I think the best thing here is that you can do all this with just the AWS SDK for Android and for Apple, right? Yeah. It's really simple to connect all of these together.
Yeah, that's true. So yeah, I think we talked a lot of the good stuff here. So let's talk maybe like one or two maybe like cons as well.
Yeah. So again, cons here I would say is it's still serverless. If you want to scale up, if you have other stuff happening on your mobile app that you want to offload, say you need product catalogs, you need ordering, you need payment processing and stuff like that. Lambda just won't hit that mark, I feel, because you need a lot of compute power to.
I think it all again depends on the scale, no, Damien?
It depends on the scale. It depends on the use case. It depends on a lot of stuff. But
but overall,
overall, this is good for a small application. The larger and larger your mobile application gets, the more features you add. For example, you need to do something like you need to say on Amazon, there's this feature on the on the Amazon mobile app. There's this feature, the Amazon e-commerce shops mobile app. There's this feature where you can scan a clothing accessory or something like that, and it will return back what exactly you scanned there. So you scan a shirt and it will say, okay, this is the shirt that you scanned. You take a picture of the shirt and it will say, okay, this is a picture of this is the item that you're looking for. So if you want that sort of complex stuff happening,
maybe it uses AWS recognition or some other service to do that.
Probably yes, but I feel like I don't think that Amazon really uses that level of AWS stuff. AWS Vision, right?
I think recognition, right?
Is it recognition or vision? I can't remember.
Image and video analysis, right?
AWS computer vision, right?
I guess this one gives
automatic recognition and description of images and videos.
Is it the same as this one?
Okay, no, that's different.
Yeah. AWS has something like Asia has something. Earlier they had a project Oxford or something like that, and turned it into Vision. Google also has a good Google Vision API. This one is the
same. Used Google Vision for some university project, right?
For face detection or something, right? We tried to do with that.
I remember. So good memories. So I mean, again, this is only, I would say this is a good starting point for a mobile app, but as you scale up more and more, you might need to add more stuff into this as well. Because let's face it, most applications don't just stick as mobile apps. They evolve and you get access to web apps and stuff like that. But say it's like, say it's something like this. What you're developing is a game on your phone that can be, it's a single player game that you can have on your phone, and you need to store leaderboard information and stuff like that, who is playing, your login information and stuff like that. This is an awesome architecture for that.
Yeah, that's true. All right. I think most of the stuff we covered. So some personal thoughts maybe. So I'd say personally, I really prefer this architecture if we are starting off a quick project, even if it's a custom application, maybe for a phase one of the project, this would be really useful and very quickly we can develop.
I feel like even more than phase one, this is completely fine, depending on what your project is.
Yes.
What you're trying to achieve.
The harder, the other side of this would be maintaining such project. Let's say we need some expertise, if we implement a such architecture, which uses core AWS services, we need some more expertise if we are trying to replace a developer. So that's one downside, just personally I'm saying, because it might be easier to find a normal, let's say, React Native or React developer than finding a dedicated, let's say, serverless guy who has worked has all hands on here. I think that's just I have to.
That's quite true. So as if you know what you're doing, if you know both mobile application development and backend development, and DevOps a little bit, and how to handle AWS infrastructure, this would be awesome for you. But if you are very sort of a simple, you are a one-man show, mobile application development, this might be a bit too much. This would be a bit too extreme for that.
In terms of
I like it. In terms of So personally, I mean, I like this because I know how to set all this up. So I like this, and if I were to develop a mobile app tomorrow, maybe it's a small game or it's a reminder app or something like that, I would definitely use this architecture.
Yes, that's perfect. Yeah. And the cost should be super low in this because we don't have any running compute instances.
Exactly. I'm not sure about the costs of cloud search.
That I'm also not clear.
It's like this. So
Lambda,
CloudFront and S3, if you abuse it, if you use a lot of storage, and if you in CloudFront, if you go to invalidate your caches and stuff, you will get a huge bill at the end of the day. But if you know what you're doing, you're fine.
Yeah, that's true. Unless we hit the limits, we know. If we hit the limits, we have to pay a large amount of.
Exactly.
All right. I think we covered both the architectures in a very good scale. Maybe it was very quick, but I feel we covered both architectures.
Exactly. Both are really cool.
I think we can cover up the other maybe like 2 more Lambda architectures in the future session, so we can directly like focus on those like differently, because these two are very relevant. This what do you call, web application and mobile. Yeah. And then I think later we can maybe go into image handler, image recognition, processing, things like that, which are a bit different use cases, because these two have like very common use cases.
Correct. Yes.
Yeah.
So personally, I haven't worked professionally with image recognition and processing or image handling. The only times I have worked with those are in university, so I might not remember it. So yeah.
Yeah, I've done it for a research project, so with like image processing part.
Okay.
But yeah, recognition.
It's a good way. I think we'll be able to identify like and talk about how this would look like in a research project versus how it would look like in an enterprise sort of.
Yes, exactly. Yeah, I think that would be a really good discussion we can take forward.
Correct. Yes.
Yeah, I think it's all good, I guess, for today. So see you guys in another video.
Exactly. Thanks guys for watching, and see you guys later. Bye.
Bye.